In this tutorial, we are going to look at a practical question from your tutorial sheet on thermochemistry. So the question is saying, the complete combustion of methane is described by the reaction. So being given a balanced chemical equation there, so we have methane plus oxygen giving us carbon dioxide and water. Okay, so that's a balanced chemical equation for the combustion of methane there. Okay, now we are saying using the mean bond enthalpy data below, estimate the standard enthalpy of combustion of methane. Okay, so being given the mean bond enthalpy for this reaction here. Okay, so now we are being asked to estimate the standard enthalpy of combustion. So being given the mean bond enthalpy, we can calculate the standard enthalpy of combustion by, so we know that standard enthalpy of combustion is going to be given by, so we are going to get the summation of the bonds that have been broken. So now if you talk about the bonds that have been broken, are those that are in the reactants, isn't it? The bonds that are present in the reactants, those are the bonds that are going to be broken. So you get the summation of the bonds broken minus the summation of the bonds that have been formed. Okay, so you get the bonds that have been formed. Okay, if you look at the bonds that have been formed, those are the bonds present in the products there. Okay, that's what we are having. So the summation of the bonds broken minus the summation of the bonds formed, we are going to get the standard enthalpy of combustion there. So the bonds we are talking about, you're going to be using the bond, the mean bond enthalpy that will be given from the table here. Okay, so let's do that. Okay, so let's look at the bonds that are present on the reactants there, the bonds that have been broken for us to get carbon dioxide and water molecule there. Okay, so here we're having CH4, isn't it? So we're having carbon being bonded to hydrogen, 4 hydrogens there. Okay, so it means that we're having 4 CH bonds. Okay, so we have 4 CH bonds. These are some of the bonds that have been broken. Apart from that, here you can see you have 2 oxygen, isn't it? So you're having 1 oxygen and another oxygen. So you know here, for us to obey the octet rule, we need to have 2 bonds between the carbon atoms, the oxygen atoms there. Okay, so it means that you are going to remain with this oxygen having 2 lone pairs, and the other one also have 2 lone pairs. So we also have O double bond O bond. So that's another bond present in the what in the reactant. Okay, and you can notice that we have a coefficient of 2. So we also have to consider that coefficient. So in this case, we can say for the summation of the bonds being broken, so we are saying we're having 4 of the CH bonds, isn't it? So we can see there for CH bond, the mean bond enthalpy is 412 there. So we're going to say 4 times 412, okay? Plus, remember we're getting the summation of the bonds that have been broken, okay? And then we are saying we're having 1 O double bond O there, which is this one. We're having 1 of it, but we have a coefficient of 2 there. So we have to consider that coefficient as well, okay? So we're going to say we have 2 times 1 of this, okay? So having 1 of the double bonds there, okay? And then the bond enthalpy for this O double bond O is 498. So we're going to multiply by 498. Okay, so the reason here we've just multiplied 4 by 4/12 because we're having a coefficient of 1 there. Okay, but here we have a coefficient of 2. We also have to consider that. Okay, so these are going to be the summation of the bonds that have been broken. Okay, so now let's go to the bonds that have been formed. So we're going to say minus the bonds that have been formed, isn't it? The summation of the bonds that have been formed. Okay, so we start with carbon dioxide there. So we know that for carbon dioxide, we have carbon being double bonded to oxygen and another oxygen the other side there. Okay, for us to obey the octet rule, meaning this oxygen will remain with two lone pairs, and the other one also remain with two lone pairs of electrons here. Okay, so it means that we are having two C double bond O bond. Okay, so we're having two C double bond to O. We have two of them, one here, the other one there. Okay, so means that within the coefficient there we have 1. So we're going to say we have 1, a coefficient of 1 times, and then we're having 2 of these C double bond O bonds. Okay, so we're going to say 2 times now the bond enthalpy for C double bond O in carbon dioxide, we're being told is 805. So we're going to multiply that by 805. Okay, then plus, so we go to water. Okay, so there's a coefficient of 2 there. We also have to consider it. So we're going to say 2 times. So now for water, you know that you're going to have oxygen having a single bond to hydrogen and another single bond to hydrogen. Then for us to obey the octet law, it means that we're going to have two lone pairs of electrons on our oxygen there. Okay. So now you notice that we are having two OH bonds. Okay, so we're having two OH bonds. Okay, so we can say we have two of them, then multiply by the bond enthalpy, or the mean bond enthalpy for OH in water is 463. So we are going to multiply that by 463 there. Okay, so now we can do our mathematics there. Okay, so we start with the first one here. Okay, so we have 4 times 4, 4. Okay, so if we do 4 times 4, 4, we are going to get 16, 4, 8. Okay, then plus, then we go to this one, we have 2 times 1, which is 2. So we're going to have 2 times 498. So there we're going to get 996. Okay, so for the units, they are in kilojoules per mole. Just remember that. Okay, so the units that we are getting are kilojoules per mole. So we can have kilojoules per mole here. Okay, then minus, so we go to the other side where there are products, okay, for the bonds that have been formed. So we start with the carbon dioxide there. We are saying we have a coefficient of 1 times 2 of the C double bond O. Okay, so we are here 1 times 2, we are getting a 2, isn't it? Then 2 times 805. Okay, so we're going to get 1610. Okay, then that plus, we have 2 times 2 there, that's 4. Then 4 times 463 there. Okay, so if we do 4 times 463, we're getting 1852. Okay, so this is also in kilojoules per mole. That's what we are having there. Okay, then we can add. Okay, so when we add our 1648 plus 96 there, we are going to get 2644. Okay, so that's a summation of 1648 and 996 there. Then we say minus, we go to the products. Okay, so we summate them as well. So we have 1610 minus 1852 there. So we are going to get, okay, so we are adding here. So 1610 plus 1852. So when we add there, we're going to get 3. Okay, so I'm getting 3462. Okay, so we can subtract there to get our final standard enthalpy of combustion for the methane there. Okay, so the final answer is going to be, so we get our 2644 minus 3464 there. So we are getting a negative answer, so which is negative 818 kilojoules. It's our final answer there. Okay, So this is kilojoules per mole. Okay, so that's the final answer for, that's the standard enthalpy of combustion of methane in this question. Okay, so you get the summation of the bonds that have been broken minus the summation of the bonds that have been formed to get your final standard enthalpy of combustion. Okay, so now there are other questions that were given this tutorial sheet. So let me just show you the tutorial sheet that I was solving. So this is the whole tutorial sheet. Okay, so that question was actually question number 2, and we have questions up to 9 there. These questions were solved and they were uploaded on the website. So if you want to access these solutions, you can access them on the website. So you simply subscribe. Okay, so how you subscribe? If you are using an iPhone phone, you can go to the website, you open your browser, then you go to our website, you just type on your browser that Discrete Learning Institute. If you are an Android user, you can download our app on Play Store. So just type Discrete Learning Institute, then you'll see the app on Play Store, download it. Then once you download, you can open our website there. Okay, so once you open our website, it will ask you to create an account. So if you have you create an account, or if you already have an account, you can subscribe to the course of your choice. So now, once you subscribe to the course of your choice, to give you the folders that are available there. Okay, so for example, if you subscribe for pharmaceutical chemistry, the tutorial sheet was gotten from pharmaceutical chemistry there. So you can go in the folder for pharmaceutical chemistry. Once you subscribe, you should be able to open the folder there. Then you have these 2 folders for first semester and second semester. So this is first semester. You pick your semester there. First semester. Okay. Once I open, I'm going to see other folders. We have recorded lessons. For lessons, you can go in that folder for recorded lessons. Then we have materials, summarized notes, assessments, and labs. I'm going to find them in that folder. Now for the past papers and tool sheet and assignments, we are going to find them in that folder, written past papers, tool sheet, and assessment. Okay, so once you open the folder, okay, so let me just wait for it to, okay, so it will show you the some of the recorded videos that are there. Okay, so you have your tool sheet 1, tool sheet 2, and tool sheet 3 questions, including the practical questions that we've been having, have been uploaded there. So for this one, this is tool sheet 3. Okay, so you go to that one. Okay, so it's written tool sheet 3, 2026. So you have questions from 1 to 4. Then you also have the other video for questions from 5 to 6 there. So you can get all the full video solution for this tutorial sheet. Thank you so much.